Hi, this is Swati. Today we are going to start our first chapter of the 10th standard, that is chemical reactions and equations. Let's start chemical reaction. Chemical reaction is a process in which one or more reactants are converted to one or more products. Chemical reaction is one process in which one or more substances react with each other and form one or more new substances. The substances which takes part in a chemical reaction or which undergo change are known as reactant, and the newly formed substances are known as products. During a chemical reaction, chemical change occurs. Now what is meant by chemical change? It is one type of change in which the chemical composition of substance changes. For example, we take that is spoiling of milk. In that what happens when the milk spoils? Its initial or at starting milk is having different taste, its color, its chemical composition, and after spoiling its state, its color and chemical composition, all the things are different. Then we are saying in that case chemical change occur, and the reaction in which chemical change occur is known as chemical reaction. The substances that undergo chemical change are called reactant, and the new substances formed is called product. Just I told that the substances which undergo change are known as reactant, and the substances which are newly formed are known as products. We'll see that with the help of one example, that is methane when react with oxygen, it gives CO2 and H2O. Now in this reaction, methane and oxygen react with each other. That's why they are known as reactants of this reaction. And they both react with each other to form two newly formed substances. Those are CO2 and H2O. That's why CO2 and H2O are the products of this reaction. And this arrow indicates the direction of chemical reaction. Change. We'll see some examples of chemical reactions. Burning of magnesium ribbon with a dazzling white flame to form white powder, that is magnesium oxide. It is due to the reaction of magnesium with oxygen in air. Now in this example, we are burning one magnesium ribbon with the help of tongue under flame, and after burning this magnesium ribbon, it can be turned into white color powder which is of magnesium oxide. When magnesium ribbon burns, it reacts with oxygen and it forms a magnesium oxide. In this reaction, magnesium turns into magnesium oxide whose chemical composition is completely changes, and that's why this is one example of chemical reaction. Next, second example of chemical reaction, that is take a lead nitrate solution in a test tube, add potassium iodide solution, a yellow precipitate of lead iodide appears at the bottom. Initially what we are doing, we are taking lead nitrate into this beaker, and in that we are adding some amount of potassium iodide. After the reaction of lead nitrate and potassium iodide, it forms a yellow colored precipitate of lead iodide. Now here, initially both the chemicals react with each other and it gives different color, that is yellow color precipitate. Means here what happens? Color also changes, state also changes. That's why we are saying this is also an example of chemical reaction. Next example of chemical reaction, that is take few zinc granules in a conical flask or test tube. Add dilute HCl or H2SO4. Bubbles are observed around zinc granules due to release of hydrogen. Conical flask becomes hot. In this conical flask, we are taking some zinc granules and in that we are adding dilute HCl or H2SO4. After that, we observe some bubbles around these zinc granules and conical flask becomes hot. Why this is happening? because the reaction of zinc granule and acid produces some amount of heat as well as it produces the hydrogen gas. That's why, because of hydrogen gas, bubbles are looking around the zinc granules and this conical flask becomes hot after this reaction. We'll learn about what is meant by chemical reaction and some examples of chemical reactions also. But how to identify the chemical reaction has taken place? There are some observations on the basis of that we can able to understand the chemical reaction has taken place. We'll see change in state, change in color, evolution of gas, and the chemical change in temperature. These observation shows that the chemical reaction has taken place. Next is types of chemical reactions. Chemical reactions are of mainly 5 types. We'll see first is a combination reactions, second decomposition reactions, third is displacement reactions, fourth double displacement reactions, and fifth is a redox reaction. Those all 5 types of reaction with example we'll see one by one. First, that is combination reaction. Combination reactions. This is the first type of chemical reaction. When two reactants combine to form a product, it is called a combination reaction. In any chemical reaction, when two or more reactants combine to form only one product, then we are saying that is an example of combination reaction. We'll see with the help of example. Here calcium oxide reacts vigorously with water to produce slate lime, that is calcium hydroxide, releasing a large amount of heat. Here calcium oxide and water react with each other to form only one product, that is calcium hydroxide, or we are saying slate lime. And this formed slate lime, when react with CO2, it forms a calcium carbonate, and after washing that calcium carbonate, it gives a shiny surface which is nothing but the marble, because the chemical composition of marble is also a calcium carbonate. In above reaction, we learn that some amount of heat is evolved. Now what are the name of those type of reactions in which heat is evolved? We'll see next. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Exo means out and thermic means temperature. The name itself indicates that the chemical reaction in which heat is given out, those are known as exothermic chemical reactions. Burning of natural gas and decomposition of vegetable matter into compost are also an example of exothermic reactions. Endothermic reaction. What is meant by endothermic reaction? We'll see. Endothermic reaction are those reactions in which heat is absorbed. The chemical reaction in which heat is absorbed, those chemical reactions are known as endothermic reactions. And in exothermic reactions, what happens? Heat is released. This endothermic is exactly opposite to that of exothermic reaction. Now during digestion, food is broken down into simpler substances. For example, rice, potatoes and bread contain carbohydrates. These carbohydrates are broken down to form a glucose. This glucose combines with oxygen in the cells of our body and provides energy. This is an endothermic reaction too. Means what? The digestion is a process. In whole process, heat is absorbed, and that is also an example of endothermic chemical reaction. Second type of reaction, that is a decomposition reaction. When a product breaks up into its constituent reactants, the reaction is termed as decomposition reaction. When one reactant is decomposed into two or more products, then we are saying that is a decomposition reaction. We'll learn with the help of example. Here, ferrous sulfate after giving heat turns into ferric oxide, sulfur dioxide and sulfur trioxide. Means only one reactant decompose into two or more products. That's why this is the example of decomposition reaction. Now here decomposition of ferrous sulfate takes place with the help of heat. Heat is used to decompose a ferrous sulfate. That's why this decomposition reaction is known as a thermal decomposition reaction. Battery. Fill the Now next subtype of decomposition reaction. First subtype, that is a thermal decomposition reaction, and next that is a electrolytic decomposition. Take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrode, and this bubble displaces water into test tubes. We will see hydrogen at the cathode and oxygen at the anode, and oxygen is a double of hydrogen in terms of volume. We are taking water in this mug and adding 2 electrons in that, and we are connect these electrodes to the battery, and after that we observe what are the changes. That water decomposes into hydrogen and oxygen. Hydrogen deposited at the cathode and the oxygen deposited at anode, and the amount of oxygen is double than the amount of hydrogen, which shows that this water which we are taking in a mug is decomposed into hydrogen and oxygen. But this decomposition takes place with the help of electricity. That's why the type of decomposition is known as electrolytic decomposition, and the reaction is known as electrolytic decomposition reaction. Next, that is photolysis, thermal decomposition. Halogen compounds decomposes on exposure to sunlight. For example, silver chloride on decomposition gives silver and chlorine. Photolytic reaction are used in black and white photography. This photolytic reaction used in a black and white photography, and in that what happens, see, the decomposition of reactant takes place with the help of light, and that is known as photolysis decomposition reaction. The decomposition reaction requires energy either in the form of heat, light or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reaction. Now for breaking down the reactants, we required energy in the form of heat, light, electricity, and depending on the source which we are used to decompose the reactant, different types of decomposition reactions are there. For example, first type, if we are using heat to decompose, then that is a thermal decomposition. If we are using light to decompose, then that is photolysis decomposition reaction. And when we are using electricity to decompose the reactant, then we are saying that is a electrolytic decomposition reaction. Next, that is third type of chemical reaction, displacement reactions. When an element displaces another element from its respective compound of lower reactivity, it is said to be a displacement reaction. If we are taking any chemical reaction, in that one chemical displaces to another chemical and form new substance, that type of chemical reaction is known as displacement reactions. We'll see with the help of one example. Here zinc react with H2S, and when zinc react with H2S, this zinc displaces to this hydrogen and form ZNS. Means this zinc takes the place of hydrogen and it forms a ZNS, and this removed hydrogen is formed as a hydrogen. Now here, why this zinc displaces to hydrogen? The displacement of chemicals, it totally depends on the activity of those elements. Here zinc is more reactive than the hydrogen. That's why zinc able to replace or displace the hydrogen from its position. The chemical reaction in which one element displaces to another element, in that type of chemical reaction is known as displacement reactions. Here one more example of displacement reaction is given. See, in this test tube we are taking copper sulfate solution and we are keeping one iron nail into that for 1 week. After 1 week, what happens? See here, in this test tube green color solution is observed and the color of the nail is also different because of the deposition of copper from this solution on this iron. Here what happens? See, the green iron sulfate solution is formed, and green iron sulfate solution is formed because iron react with that sulfate from the copper sulfate, and the color of copper sulfate is blue, but because of the replacement of iron from that copper, it forms a green color solution. Means what here? Here iron replaces to copper. The meaning of that is iron is more reactive than the copper. That's why iron able to replace the copper, and so that the copper sulfate when react with iron, it forms a green colored iron sulfate. This is also a type of displacement reaction because one element displaces to another element in this reaction. Next, fourth type of chemical reaction, that is a double displacement reactions. Before this we learn single displacement reaction, or we are not saying single, only displacement reaction we are saying. But here fourth type, that is a double displacement reaction. We'll see what is given in this. Reactions in which there is an exchange of ions between the reactants are called double displacement reactions. These reactions are also called precipitation reactions, as an insoluble substance is formed which is known as precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Now in this reaction what happens? The ions changes their position to form a precipitate. Precipitate means the formation of solid substance, and in this reaction precipitate is formed. That's why the name of this double displacement reaction is also the precipitation reactions. We'll see with the example that in double displacement reaction, silver nitrate when react with sodium chloride, what happens? Here Ag replaces to this sodium and it forms a silver chloride, and the sodium from NaCl react with NO3 from AgNO3 to form a sodium nitrate. Means here what? Silver and sodium both displaces to each other. Means two elements, two ion displaces their position. That's why we are saying the name is a double displacement reaction. And generally in most of the time what happens? In double displacement reaction precipitate is formed. That's why it is also known as a precipitation reaction. Examples of precipitation reactions which is also a double displacement reaction, just we learn that. Now what we are doing, we are taking solution containing Ag plus and NO3 minus ions, which is silver nitrate solution, and in that what we are doing, we are adding the one type of solution in which K plus and chromate ions are present. Means that is the solution of potassium chromate. After the reaction of those both, we get the mixture containing K plus and NO3 minus in solution and insoluble solid as Ag2CrO3, which is silver chromate we get. The precipitate of silver chromate is formed here, and that's why this silver chromate is a precipitate, and that's why we are saying this is an example of precipitation reaction. And in this 2 times displacement is occur, that's why this is also an example of double displacement. Next type of chemical reaction, that is oxidation and reduction. When in any chemical oxidation and reduction takes at a time, then we are saying a redox reaction. Now we'll see first what is meant by oxidation reactions. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. For example, in chemical reaction, if in that reaction gain of oxygen takes place, then that is known as oxidation reaction. If loss of oxygen takes place, then that is known as reduction reaction. Gain of oxygen is oxidation and loss of oxygen is known as reduction. If one reactant gets oxidized while the other gets reduced during a reaction, such a reactions are called oxidation reduction reactions or redox reactions. If a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gain hydrogen during a reaction, it is reduced. For example, how we are saying that gain of oxygen and losses of hydrogen are known as oxidation. Exactly reverse to that is gain of hydrogen and loss of oxygen is known as reduction. Help of reaction will try to understand what is meant by redox reaction. The chemical reaction means oxidation and reduction takes place in one reaction, then we are saying that is the example of redox reactions. See, methane when react with oxygen, it gives CO2 and H2. Now here, methane when react with oxygen, it gives CO2, H2O, that we know. But when it react CH4, what happens? It undergo oxidation. Means what? It loses hydrogen, and the loss of hydrogen is known as what? Oxidation. CH4 loses its hydrogen and react with oxygen to form a CO2. That's why we are saying methane undergo oxidation. And next, that oxygen, it accepts the hydrogen and forms a water. That's why we are saying that undergo reduction. Now what? Addition of hydrogen is known as what? Reduction. And the loss of hydrogen is known as what? Oxidation. That's why here methane loses hydrogen, so oxidation takes place, and oxygen gains hydrogen, that's why reduction takes place here. In this reaction, both oxidation and reduction occur, that's why this chemical reaction is the example of redox reaction. Now below here some examples of chemical reactions are given, 1, 2, 3 examples. You can try to identify each example of which type of chemical reaction. Corrosion and rancidity. Now what is meant by corrosion and rancidity, we'll see. When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called a corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. We know that the rusting of iron, in that what happens, iron get oxidized to form a ferric oxide. That time what happens, it undergo corrode, we are saying, and that process is known as corrosion. Same like that, iron, copper and other metals also undergo corrosion, or they are corroded because of the process of oxidation. When they react with oxygen, they are corroded. Now corrosion causes damage to car bodies, bridges, iron railings, ships and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. See, cars, or bridges, they undergo corrosion because of the continuous contact in water and oxygen. And this is a very serious problem to damage these substances like iron, car and bridges, all the things. When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation, those are known as antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers help to slow down oxidation, and this prevents the food from becoming rancid, and hence chips are flushed with nitrogen just to prevent it with the rancidity. Now rancidity means what? When any food reacts with oxygen, its taste, its smell changes, and because of the change of oxidation, the taste and color of the substance changes, and that's why it is not able to take easily. When fats and oil are oxidized, they become rancid and their smell and taste become changes. Now why this is happening? Because when they react with oxygen, its taste and color changes, and that process is known as rancidity. Generally the chips and all the foods which we are taking from the market, they are closely packed, but to prevent the oxidation of that food, some types of substances are added in that which prevent for oxidation, and those substances are known as antioxidants. The substances which prevent the oxidation process are known as antioxidants, and those antioxidants are added in a preserved food to prevent the oxidation. For example, in chips, nitrogen gas is added to prevent the oxidation of that chips so that they cannot be changed its taste and color. This is all about the corrosion and rancidity. In this part we learn about chemical reaction, its different types with examples. In next part we'll see what is meant by chemical equation, how to write a chemical equation and how to balance it, and why need to balance the chemical reaction.